All right, guys, we're going to finish up factoring today, and there's just a couple of small rules that you need to know about factoring, and they're called the special cases. These are they don't apply to anything else. The first special case is called a difference of squares, and this is when you need to realize you're factoring things that are where both terms are perfect squares. So as we look at this first one here, and I'm going to look at this a squared and b squared are both perfect squares. I'm going to come back to this one because this is our general rule. Let's look at this one. N squared minus 25. These are both perfect squares. N is a perfect square because n times n equals n squared. These factor out to be n minus 5 times n plus 5. And every perfect square will follow this rule where it's the variable times the numbers that become that perfect square. I'm going to show you why real quick that is. If we refoil this back out, n times n is n squared. N times 5 is 5n. Negative 5 times n is minus 5n. And negative 5 times 5 becomes minus 25. These middle terms cancel out, so I'm left with n squared minus 25, which is what I started with. Anytime you have two perfect squares, so for example up here, it's your first variable and your second term, it's the factors that make up those two terms. It will always be in that form. Always, always, always. So, and we could refoil this out as well. A times a is a squared. A times b is ab. A times negative b is minus ab. And then negative b times b is minus b squared. Middle terms cancel. I'm back to a squared minus b squared. Looking at this example down here, I need to start by realizing there's an x and a y, but that's okay. Starting with what makes up 36, that would be 6. And it's 6x, because that's what that 36 is going on there. And then 49, that is 7. So we need a minus 7y, because there's a y with that. And then I'm going to need the opposite factor to make sure that my middle terms cancel when I FOIL. So if you're not really sure, I would FOIL it just to make sure. Let's just double check that. 6x times 6x is 36x squared. 6x times 7y is 42xy. And now I can already see this shaping up here, that when I multiply my inner terms, that negative 42xy will make that piece cancel. And then my last two terms, oh, that's not 7, that is 49y squared. So I know I'm in the good. And that's pretty much what a difference of squares is. It's recognizing both things are perfect squares, and you're unfactoring it to find these factors. I'm going to have you pause the video and try this right column. Welcome back. As you can see, I've answered these three over here. Hopefully your answers match mine for the difference of squares. That's pretty much all these is. So we're going to keep going, but if you're confused about something, maybe rewind the video and watch that section again. Okay, let's jump to section 2. As we look at these, there's only two terms, and sometimes we can pull out a common factor before we begin factoring. So look at this first one here. I'm looking at 48a cubed and negative 12a. And I can see that I can pull out a 4 and an a. Once I pull out the 4a, what's left on the inside is, that's a 12a squared, because 48 divided by 4 is 12. And at the end, I've got a 3. Looking at my inside piece, the last thing you should see is there anything else I can pull out of here? Is there anything else they share? And the answer to this is no. So at this point, I'm done. So that ones like that are really nice. As we look at this next one, there's a little bit more to it. But you're still going to do this first step first. You know, what can I pull out of here? I can pull out an 8. So when I pull out an 8, I'm going to be left with y squared. And if you do 200 divided by 8, you're going to be left with 25. Now, as you're looking at this inner piece here, something should stand out to you. And this is a difference of squares. These are both perfect square things. So recognizing that's going to allow you to break down this into two factors as y minus 5 and y plus 5. So this has three factors: 8, y minus 5, and y plus 5. And this is our answer. You could refoil this out, redistribute everything, and you'll get back to your original piece, but everything now is factored completely. I'm going to have you pause this video and try these two at the bottom. All right, welcome back. As you can see, I've only done one example for you. Hopefully that one made sense. That was a pretty simple one. The second one, though, I do want to talk about, this one is a difference of squares, and it doesn't look like it because this exponent is not 2. But I know that a squared times a squared makes a to the 4th. So when I write this as a difference of squares, a squared times a squared will get me that piece. And then 81 is a perfect square, which is 9 times 9. So breaking it into these two factors will bring me to a to the 4th minus 81. But we're not quite done because I have another difference of squares right here. A squared minus 9 is a difference of squares because a plus 3 and a minus 3 are factors of a squared minus 9. And then a squared plus 9 is not a difference of squares because that's a plus sign there. Difference of squares, keyword difference, means subtract. So subtracting two perfect square things. So this has 3 factors to get to a to the 4th minus 81. And again, you could refoil everything and get back to that part. Moving right along, so we're going to apply all of our knowledge of factoring, including grouping and difference of squares. Before we get started, I made a stupid mistake. This should be squared right there. 5x cubed plus 15x squared minus 5x minus 15. Sorry, write that in, but I'm glad I caught that now. As we're looking here, these all share a 5. So I'm going to actually start by factoring out a 5. When I do that, I'm going to be left with x cubed plus 3x squared minus x minus 3. Now, as I'm looking at the inside of this, there are 4 terms and they don't share anything. So at this point now, I'm going to group them. And this is what we're talking about grouping. What can I pull out of this first set? I can pull out an x squared. And I can pull out nothing else. So left on the inside is x plus 3. And don't forget my 5 is still up top. So that's just going to drop down with me. And then out of the second group, I can factor out a -1, which leaves me with x plus 3. Perfect. So these match. I know I'm good there. So I've got x plus 3. And the second two terms are 5x squared minus 1. You could then redistribute everything and make sure that it's good, and it will be, and you're done. Perfect. I'm now going to have you pause the video and try this one on its own. I will give you a hint before you start. This one's going to involve some difference of squares. Okay, so first I'm going to look and see if I can factor anything out, and I can't. So I'm going to start by grouping because there are 4 terms here. Out of this first set, I can pull out an n squared, and I'm going to be left with n plus 5. And over here, I can pull out -4, which is going to leave me with n plus 5 again. So beautiful, that was awesome. Over here, I'm left with n squared minus 4 and n plus 5. Now, I gave you a hint before. There's a difference of squares in here, and it's right here. N squared minus 4 is a difference of squares. That could be broken into n minus 2 and n plus 2. And then you have n plus 5. So these are my factors. Here they are. Multiply these back out, you will get back to this polynomial. Excellent. Hope you followed that. Just kidding, there's 2 more parts. Sorry. Don't forget, if you are looking for solutions, and that's what we are because these are equations. Anytime there's an equation, you're looking for a solution, and you're going to have to set each factor equal to 0 and solve. So this first one, I've got to get everything on the same side of the equal sign. And when I do that, I will be left with 18x cubed minus 50x equals 0. First question is, what can I pull out of here? I can pull out an x. I can also pull out a 2. And so I'm going to be left with 9x squared minus 25. And, oh, wow, once again, there's another difference of squares. So this will become 3x minus 5 and 3x plus 5. Hopefully you're starting to get the hang of these difference of squares. And you also have a factor of 2x. So as we said before, these are a little bit different because you're looking for solutions and you have to set each factor equal to 0. You have 3 factors here. So I'm going to have to set 2x equal to 0. We're going to have to set 3x minus 5 equal to 0. And we're going to have to set 3x plus 5 equal to 0. Once we solve these, we're going to find out that x equals 0 and x equals 5/3 and x equals negative 5/3. There are 3 solutions here. If you were to check this on Desmos, you will find there are 3 x-intercepts, 3 solutions. So we're good. I'm now going to have you pause this and try this one here. So in this example here, after you pause it, hopefully you first factored out an 8m because they each shared an 8 and m, and you're left with m squared minus 16. M squared minus 16 is a difference of squares broken into parts m minus 4 and m plus 4. I can no longer factor anything, so these are the 3 factors, but we're looking for solutions because this is an equation. Once I set each factor equal to 0, I find that the solutions are at 0, 4, and negative 4. Moving along to the last slide here, you could also use the perfect square property, and this is a shortcut. Check this out. If each side of the equal sign is a perfect square, you can take the square root of both sides. The square root of x squared is x, and the square root of 9, we're going to call that plus or minus 3, because x could be positive 3, because 3 squared is 9, or it could be minus 3, negative 3, because negative 3 times negative 3 is positive 9. What that means is my solutions, because this is an equation, my x-intercepts are at 3 and at negative 3. And if you were to look at that, you would see that here we have solutions at 3 and negative 3. So as we look at these, this next one up top, we take the square root of both sides, and that's okay to do. I have the square root of a plus 4 squared is just a plus 4. It cancels out that square root. And the square root of 49 is plus or minus 7. It could be positive 7 or minus 7. When I'm looking for solutions, I need to set a plus 4 equal to both 7s, either positive 7 and negative 7. And I find that my solutions should be at 3 and at negative 11. And then looking at Desmos, sure enough, there they are at negative 11 and at 3. I'm going to have you pause the video and try these 2 down below. This one's a hard one, so be careful. Alright, first one over here, they are both perfect squares, so I take the square root of each side. I'm left with 5x, x squared root, x squared square root. Remember, that divides it by 2. Remember that property there. You're left with just x and then plus or minus 6. When you solve this, means 5x is equal to positive 6 and 5x is equal to negative 6. So its solutions, its zeros, x-intercepts, are at 6, 5, and negative 6/5. This one over here, I said it's just not that it's hard, it's just weird. As we look here, y minus 8 is equal to the square root of 7 and to the negative square root of 7. So when I solve these and do like plus 8 on each side, you can just leave them as like square root of 7 plus 8. You do not need to actually find that math. So, and same over here. Did I do that? Yeah, this should be minus. So this would be negative root 7 minus 8. You don't actually have to solve that out. You're done. There's your 2 roots. That was a terrible circle. So sorry. Cool. So you're going to try the worksheet now. Some of this is on there, and there's also a review of other stuff. Excellent. Hope you guys had a great day.